All right, good afternoon team. What we're going to look at is how it might look for me to do calculations digitally straight on the screen using some sort of touchpad, stylus, etc., and how it also might appear if I am talking over the slides and trying to highlight information. So what we might do is, I've got a laser pointer here, some sort of indicator as to where I'm looking on a slide. So if I did want to point out that it is example 1.2, I'm looking specifically at a golf ball, there's a specific section of a diagram that I want to highlight. This should be pretty clear. Okay, so we're going to look at maybe how I could provide work solutions for you guys. So a golf ball is projected horizontally off a cliff at 20 meters per second. It takes 4 seconds to reach the ground. Calculate how far out from the base of the cliff the ball will land. Now, of course, if you push next in the slides, it will give you the solution and it'll show you how they came to their final answer. And if you want to see me talk over this solution, there's a few things we can do. I can talk you through exactly what they are doing like this, or of course, I can move over to my own PowerPoint here, get rid of this out the road, and I can do the exact same working. So for example, I can set up a diagram where I've got a little cliff, I've got a golf ball going off the side here, and it is going to be going off at 20 meters per second. Maybe I'll put the red pen on. Okay, so we're going off at 20 meters per second here. Now this is all of this is going to be horizontal motion. There is no vertical motion in this. So we can set up our suvat down the side. Okay. Now, we don't know how far it's going to be traveling. That is actually what we're trying to calculate, how far out, which is going to be our displacement. My initial velocity is 20 meters per second. At the end, it'll also be 20 meters per second because in the horizontal direction, there is no acceleration or deceleration. And as we can see up here, it takes 4 seconds to hit the ground. So my time is going to be 4 seconds. Now this is a nice easy solution here. It is just displacement equals initial velocity times time. So S equals 20 times T, which is just, well, 20 times 4. So we have 80 meters is how far it is going to be traveling out from the base of our cliff. So if the base of our cliff is here, it is going to end up traveling out 80 meters. And of course, going back to the slides, we've got the same solution here. Okay, moving on to the next question here. It says, for a golf ball in worked example 1.2a, which is the example we just did, 1.2a, okay, it's now going to say, let's calculate the impact velocity in the vertical direction and the height of the cliff. So again, I can just jump to another slide here. It says for the golf ball in 1.2, calculate impact velocity and height. So we can start off with a pen again. Okay, here's my cliff, here's my golf ball. It is going to be traveling down, obviously. We can start off setting up a suvat once again. Now, we don't know how far it is going to travel down. That's what we're going to work out when we get the height. So that's unknown. How fast is it traveling at the start? Well, 0 meters per second because all the velocity at the start was straight across. It was all horizontal at the start. So in terms of the vertical direction, nothing. How fast is it going to travel at the end? It is going to be traveling at some sort of unknown speed or unknown velocity. That's actually what we're solving for part A. How fast is it accelerating? Well, minus 9.8 meters per second squared because gravity is accelerating it. And how long is it going to be in the air for? Well, it's going to be in the air for 4 seconds because that is how long it said in the very first part from 1.2a. It was in the air here for 4 seconds. So let's do a solution. Now, before it was all horizontal, and that's all we cared about. In this run, it is going to be all vertical. So let's solve for part A, the impact velocity. I've got U, I want V, I've got A, I've got T. Go to your formula booklet. We can easily pick out this formula nice and quick. Don't even need to rearrange it. It is going to be 0 plus minus 9.8 times by 4. So we have minus 39.2 meters per second. Now, of course, it is minus because it is going to be traveling downwards. So, nice easy solution. Once I've got this, I can fill it in here if I want. I can get rid of this question mark and I could say that is minus 39.2 meters per second. I can circle it, I can underline it. We can go up here, I can highlight it just to make sure, yep, that is the final solution for that question. Better put the right pen back on. Now I need to still calculate S, my part B of this question. So part B, I'm going to be calculating S. Now I could use V in my calculation. However, like we said, we're going to try and always avoid using a pre-calculated value in our next calculation, just in case there was a mistake here with this. So I want to get S. I've always had U, I've always had A, I've always had T, because this is what was given to me in my question. So I need to find a formula that uses S, U, A, and T. Okay, we've got our lovely formula, S equals UT plus half AT squared. So let's fill in our knowns. S equals, well, that's just 0, plus half times minus 9.8 times 4 squared. S equals 0 plus, now we've got, put it in my calculator, half times 9.8. Better put in the correct bit of my calculator. Half times minus 9.8 times 4 squared is going to give me, where's my stylus gone? There we go. Minus 78.4, which is just overall minus 78.4 meters. So it has gone down 78.4 meters, and I can now fill this one in, minus 78.4 meters. So once I got my final answer, I could of course do the same as we did before, give it a highlight just so we know that that is the final answer. Now, you will have the work solution again provided by the textbook. You've got a few choices. You can either have me talk through this solution and how they got theirs. I can possibly turn the pen function on and scribble on their solution. So let's say we look at this, and I say, oh, we don't need the X, we don't need the Y. This is all, because it is the Y, that means it is going to be everything to do with vertical. I can scribble over the slides like this, or of course I can do an entirely new slide with all my working on a different slide. It is your choice. Okay, of course, if you want to look through the working again, you will have your normal PowerPoint slides given to you as per usual. And if you want to pause the video, for example, and look at my work solutions, you can do that. So basically what I want from you guys is tell me, would you prefer working out on a notepad as a video, or would you prefer the working out like this, because it actually lets you see questions nice and easily, and there's probably a bit more scope to actually view more of the question, whereas the notepad, I had to sort of move it around to be able to get the question and the solution in there. If you guys could let me know, that would be